of Leetcode problem 877 still game. So first of all, let me explain the question and also about the game theory. So the question is, we are given a pile of steals and we have a number from the left to the right. It is 5, 3, 4, and 5. And there are going to be two persons, Alice and Bob. So A for Alice and B for Bob. For each of the turn, Alice can take a pile of steals from the left side or the right side, and also for the Bob. But Alice will take first. So for Alice will always choose optimally, maybe left side or maybe right side. And for Bob, while Alice has taken one, so what left behind for Bob is also taken optimally from left side or right side. So this is a basic game theory problem. Normally we can solve it by using dynamic programming. So the idea is that for Alice will take the steals first, and Alice will always choose the maximum value of all the possible results. And for Bob, also wanted to take optimally, Bob also wanted to take the maximum value of all the possible results. But for our DFS, dynamic programming, so here I'm going to use the DFS with memorization. So DFS can only define for one person. It cannot define two persons optimally. So for DFS, we're going to define it is for Alice. If Alice can take the steals optimally, and what is the maximum number of steals Alice can take. So this is the definition of DFS. So for each turn, Alice will take the maximum of all the possible results. So for example, the final return have some values like 5, 6, and 7. So Alice will finally choose to take this 7 because 7 is the maximum. And for Bob, Bob will return something to Alice. So this means Bob will not take optimally. Bob will return something. So Bob will return the smallest value to Alice. Maybe for this turn, Bob has a value of 5, 6, and 7. So for Bob will give a value 5 to Alice. And maybe another DFS, Bob gets some result, maybe 6, 7, and 8. And Bob will give this smallest value to Alice. And also another one, maybe Bob gets something for 7, 8, and 10. And Bob definitely will give 7 to Alice because Bob also wants to win the game. Yeah. Now, what for Alice? Maybe Alice also takes some other steals, and with the value Bob given to Alice, maybe Alice can also take the steals with a 3 plus 5 for this turn. And maybe this turn is 1 plus 6. Maybe another turn is 2 plus 7. So finally, Alice will choose the maximum number. It's going to be 7 plus 2. It's going to be 9. And this is the whole operation of the process. So if you understand that, basically you can design the DFS function. So the function is going to be from the L to R, I mean for left side and right side, and we also need a Boolean value true to decide which one runs first. So this true means Alice will take the first turn to take the steals, and then Bob. So basically we're going to need the 3 variables for the DFS, and the return is going to be the maximum number of steals Alice can take. Yeah. Now we can try to solve the problem. We can prepare a case for the DFS, and inside of the DFS, it's going to be L and R, and a Boolean value, so it's going to be Alice. So this means Alice will take first. So I'm going to prepare a half, as for this game there will always be a winner. So the half going to be the total of piles, the sum of piles divided by 2, and I'm going to have a result. So I'm going to call the DFS. So it's from the left side 0 and right side of length of piles minus 1, and also a Boolean value. I'm going to set it to true. This means Alice will take first. So the final return is going to be result more than half. So the result, the DFS, just means if Alice can take the steals optimally, and how many steals Alice can get. So from the left side and the right side, and Alice start first. So this is the definition of the DFS. Now from here, so if this L should always less than and equal to R, but if this L is more than R, definitely we're gonna give a 0. So this means we cannot take the steals anymore. Now we're gonna check a result. It's gonna define two variables. One is for Alice and one is for Bob. For Alice, I'm gonna always take the maximum value, so I'm gonna define minus infinity. So if this term is Alice, so else it is for Bob. Bob will always choose the minimum value, so I'm gonna define an infinity for the Bob. Now I'm gonna check the term. If this term is for Alice, so my result gonna be the maximum of all the possible results. So it's gonna be the DFS. I'm gonna first take from the left side, L plus 1 to R, and I'm gonna give a false, because the next term will be Bob. And I'm gonna plus the piles from the left side. And similarly, I'm gonna choose the right side, so it's gonna be L, R minus 1, and false. And for the right side, I need to plus a value of piles from the right side. Yeah. So this is for Alice. So what about for Bob? Bob will return something and give it to Alice. So the result gonna be the minimum. So this is why I define the infinity for Bob, because Bob will choose the minimum. It's gonna be the result, and we can copy the lines from here. But for Bob, we'll return something for Alice, but this one is actually taken for Bob. So Bob will not give it to Alice, because Bob will take something. And this return is just for giving something to Alice, so we don't need to plus the piles L and R, because this one is belonged to Bob. Because Bob takes something and I cannot take something to Alice. I can only take the left behind things to Alice. Yeah, so let me give you an example. So this is the array, and this is 3, 5, 6, 4. So when Bob takes these values 4 or 3, Bob will not give the value to Alice. Bob will only give what left behind to Alice, and what left behind may have the minimum value, and Bob will only give the minimum value of the left behind to Alice. Yeah. Now we need to have a final return for the result. So this gonna be the maximum of steals Alice can take. If this result is more than half, this means Alice wins, otherwise she loses. So this is going to be the entire code. Now let me run it to check if it works. Yeah, so this is a false. Yeah, because I forgot to delete this area, so we don't need to plus anything for Bob, because Bob will give it the left behind to Alice. Now let me run it to check. Yeah, because I forgot to set it to Alice, because here the Boolean value should be true. Because this term is for Alice, and the next term gonna be Bob, so I'm gonna set it to false. And while it goes to Bob, I need to set it to true, because after this term, the next term gonna be Alice. Yeah. Now let me just run it to check. Now as you can see, it works. Now let me submit it to check if it can pass for all testing cases. Yeah, as you can see, it works. Now let's analyze a little bit about the time complexity. As the pile's length is just 500, so this is going to be N, and this is L and R. And inside, as you can see, there's no for loop, so the time complexity would be L times R. And this L and R can have 500 different cases, so it's going to be N squared. So normally it's gonna be this kind of L to R. It can be 0. For L, it can be 0 to n minus 1. And for R, it can also be 0 to n minus 1. Because if this is for Alice and Bob can choose all different cases, yeah. So basically there will be n squared different cases. So that's going to be the time complexity. And for Alice, that is just a Boolean value, so we're going to ignore that because there is only 2 different cases, true or false. But we will only consider this L and R, so it's going to be n squared for the time complexity. Thank you for watching. See you next time.